welcome to Let's Make It. This is episode 10, and this week we're going to walk through how to take an Ethernet shield, add it to an Arduino, and then check the status of a stream or an internet viewing stream and turn things on or off depending on its status. And I talked about this a little bit last week. If I got all the parts, I would do this. And I did get all the parts, by the way, this is actually not streaming live, and a couple of reasons. I'm actually recording this on Sunday before the Tuesday that it would normally be recorded live. I have another commitment that I cannot make the show. And the other thing is, if I did this during the live stream on Tuesday, I would have to take the stream down to show you what it does. So I am going to take the stream down Sunday. Hopefully nobody's watching as I do this and they aren't bothered by this. But I am going to take the stream up and down to demonstrate what this does. So the problem I've been having is the stream will not stay up for always long periods of time. So in my mind, it's like I've been nice if I had a visual indication instead of having to go to a website or something like that to see it as online. And I think like, well, I can make this look pretty and do it like the old on-air lights like they have in radio stations. So I haven't built the on-air light yet. I've looked around and I've seen some commercial ones that I could probably adapt to do this. But I'm kind of wanting to maybe build it myself. So I'm having trouble finding the boxes to make the light. I mean, I have the LEDs and everything else I need. All I need is the box to put it in. And I'm not necessarily real good with woodwork, so I haven't attempted to build a box. So that may end up being what I have to do. So that'll make it a little less pretty, probably, if I have to make the box. So, but what I have right now is I have an Arduino with an Ethernet shield, and I'm going to walk through the code that can determine if the stream is online or offline. And I'm going to walk through that. So first, let's look at the Arduino Shield. So we come over here. So this is all, and we're not going to look at this very much today because there's not much to it. Basically, it's a shield that goes on top of the Arduino, and you see I have an Ethernet cable plugged in right there, and that's pretty much all there is to it. I got this from SandSmart, and you can see it does have a place to plug in memory card if you wanted to. In this case, I do not have any need for memory card, so it's just blank. And you see the lights right here, and these are basically link lights. You'll see the link lights and things down here as well on this, but they're also right here. And you see transmit and receive, link, or the power. Let's see what else is on this little list right here. Can't read upside down. The speed and duplex is on here, things like that. So you pretty much can see the status of everything right here. So we're not going to spend much time looking at the board because everything that you need to look at is actually in code. But just kind of notice what's attached to it. It's an Arduino Uno. You can tell by looking underneath there or on the back somewhere. I don't know what I say, but it's an Arduino Uno. So it's one of the ones that I've had here before. So like I said, we're going to spend most of our time today looking at the code in the serial interface. I've developed it so it tells you what it's doing, so you can kind of walk through it as well. The program is one of the more complicated ones, really, that we've looked at, and it introduces a couple of additional things that we should probably talk about as well. A new library that I had to download from somewhere. In addition to the Ethernet Shield works with the library that comes with the Arduino for the Ethernet. So it right out of the box just worked. I was thought maybe a separate library for that, but it doesn't. It's exactly the same, even though it's not really from the Arduino manufacturer. It's from SandSmart. So that's one thing to note. So okay, let's go over and look at some code. Let me get back to the top, and here's the code. And you see I didn't change the name yet. Actually, this has not been commented very well yet either. I will comment it better before I stick it up on the site. But let's kind of walk through what we need here. And there's a couple of things we've seen here before, something we saw here before. I don't know if you remember the serial display, but we had to use SPI for the serial display. So you see I'm including that. That's because this Arduino, this Ethernet shield talks using SPI. So that's how it's transferring data, is using the SPI protocol. The same thing we used for that display before. You see a new one we've never seen before, Ethernet.h. This is the one that comes with the Arduino libraries. So nothing special, we just include Ethernet.h. And then we come up with one that is a little different from before. And it's a JSON. So we never talked about JSON before, and it's something that's most popular in web development. It's kind of like XML, but not XML. It's a way of transferring data. And what I want to do is I want to go down here. I'm going to, where is it? take this URL and show you what comes back. I'm going to find the URL right there. It is. Let me take this, and I'm going to bring up a web browser. And I'm going to go to, it's Ustream.com, and then it's too much stuff in here. Let me get rid of this. And status. So this is what we're going to get back. And let me increase this a little bit so you can see it better. So what we're going to get back, and this is because I'm looking at it in JSON. This is the format for JSON. And it's basically an array, and it says that the result is live. So right now the stream is up. There is no message. There is no error. Process time is true. I'm not quite sure what that actually means. And then this is their version of, I'm assuming this is an internal version. Now I could get this different ways. I'm using JSON because I know JSON very well. I also know XML very well. So I could have, instead of saying JSON right here, said I want it in XML form, and I'll get it like this. And I could have used an XML library. To me, JSON's a lot shorter as far as transfer time goes, so I just picked that one. You can also get it, I know HTML for sure. If you put it in this in HTML, and you get it like this. So there's many ways you can get it. JSON just seems to be the simplest to me. So we will get back data like this. So right now the result is live. I am going to take the stream down real quick, and we'll show you what happens when the stream is not live. So let me go over here and stop the stream. And I'm not quite sure how fast this updates. We're going to try it right now, though. Let's refresh. So it's live. I think I read somewhere it can take up to a minute. And we're going to sit here, we're going to wait. All right, the magic of editing, you probably didn't see that, but it took about a minute or so for it to show offline. So now the stream is down, so the result is offline. And you see, again, the message, no error, process time is equal to true, in the same version we had before. So the only thing that changed was the offline. So what we need to look for in the Arduino is either offline or live. So let's go ahead and get back over to the code. And we're going to go back to the top up here. All right, so let's go on down through the code a little bit more. So we got to the JSON, which is where I took the little detour there to show you what the JSON would look like. And so after we include all the information, all the libraries that we need, and all the headers that we need, we come down, and the Shield has a MAC address, and it's not, the one I have does not have predefined on it what the MAC address is. However, I did read that some of the ones you buy do have a sticker on them that has the MAC address on them, and that's what you should probably stick in here. A MAC address is the address that is assigned to the hardware, and it's generally represented in hexadecimal. So like DEADBEEF FEED is the actual address. This was one that came in the example that I had. I just kept the same one because my board doesn't really have a MAC address. And if I remember correctly, DE is unassigned, so it's really not going to be conflicting with anything that's official. So the next thing we need to do is we need to tell the Ethernet where the server is. So basically, I'm going to be a client. So I need to tell it where do I want it to talk to. And I looked up Ustream. I basically did a ping to ustream.com, and it came back with this IP address right here. It's 199.66.238.68. The next line, we are going to assign the control pin, and what I'm using this for is when my stream is live, I'm making this pin go high. When the stream is not live, the pin goes low. So at that point, I pretty much can control anything that I wanted to control using that one pin. This pin could be a bunch of other different pins. The 4 pins that are used for the SPI, I'd have to look, I can't remember what they were, but they're higher. I think they're like 9, 10, 11, and 12 maybe, something up like that. So the ones beneath that are available for you to use for your purposes. And 13 was not being used either. So I just stuck with 13 because there was a light on the board for 13. Then we come down, and these are kind of like our state. We have a version of a state table, a very simple yes or no state table. And that's what reading is. Basically, reading is equal to false. And I will change the code and show you why we do that. And then we have the current character position, which is used later on as we bring in the data, and we'll show you that as well. This is the array that we bring back in. And then we have the variable, is it live or is it not live? So is it up or down? You know, basically if it says it's equal to live, then we say it's equal to true. And we use that to do different things. So it's going down here a little farther. We initialize the Ethernet library by calling Ethernet client, and then we're going to call the variable or the structure client. Actually, I guess it's probably considered a class right here. So the client class. We come into our setup, and first thing we do is we define a variable saying we connected. And this is how we are initializing the Ethernet. So if we didn't do this, and let's say, for example, you turned this on but didn't plug the Ethernet in, it would fail immediately, and it would stop if we just didn't loop. So what we're basically saying is, until we get connected, which means we get an IP address, we're going to keep looping. So this is the variable that keeps track of that. We set up our pin mode for pin 13, the way I defined up top, to be an output. And I'm turning on the serial port so I can watch what's going on. And we're going to watch the serial port under different scenarios so we can see what it does. And then we go through, here's the loop right here, this do and the while. So everything inside here, we're going to do this at least one time. We're going to say trying to get an IP address, and we're going to initialize the Ethernet and give it the MAC address. And if it comes back that it's equal to 0, it means that it did not get a DHCP address or get an IP address. So we're going to say we connected was false, and we're going to wait 1 minute. After 1 minute, we're going to drop out of this, come down to the bottom of the while. We're not connected, so we're going to go back to the top again. We're going to say trying to get an IP address, and we're going to wait again for the timeout period. And if we don't get it again, we're going to sit in the same loop that we did before. However, if we do get it, what I'm going to do is print out the local IP address and going to say we connected. So we drop out of this while loop right here. And based on some things that I read, we need to delay 1 second to let the Ethernet shield initialize. So I'm going to wait 1 second and then tell you that I'm going to connect. And then going to go back into our loop. So the first thing I'm going to do in the loop is do a subroutine I wrote called CheckStream. And when it gets done with that, it's going to wait 1 minute and then do it again. It's going to do this forever. It's going to sit in this loop forever. So let's look what CheckStream does. And first thing we do in CheckStream is we set our reading variable equal to false because we're starting from scratch each time. We're setting our array position equal to 0. And we are creating a JSON object called root. And that's when we do that. We come down and we do a client connect to the server address that I assigned above on port 80. Port 80 is what we use for web interfaces. And if it connects okay, it's the TCP connection. If it connects okay, it's going to say I connected right here on the serial port. Then the client's going to send out the command get space, and then this is the URL. It's JSON channel, and then TextNTV is our channel name. Again, the get value of, and then status. And then we're going to put a space, and the next thing we send out is the version number that we're requesting over. And then we send a blank line. This tells the server that we are done. Here's what our command was. So we send the blank line. And we come down, and while we remain connected, so the way HTTP works is you set up a connection, you give it a command, you get back your results, and then the connection drops. So what we're saying right here is while we are still getting data back from the server, basically what this while loop is going to do. So they're going to do this stuff. So what we're basically going to do now is if the client connected is still connected, and if there's characters waiting to be read, then I'm going to read one character, and I'm going to put it in the character value of C. And if that value is equal to this left squiggly bracket, I'm going to say reading equals true. So basically what I'm doing here and what this is accomplishing is when you get back data from your request, you're going to get back a bunch of header information that you don't need. So you want to ignore that. So you can ignore everything up until this first bracket, which is where the JSON start is. So at that point we say reading equals true. And reading equals true will stay that way through this whole rest of the while loop. We'll never turn it back off until we restart the subroutine over again. So we turn reading on. So now if we get down here and we are reading characters, I basically wanted to take that character that I read, including this bracket, because this bracket is a very important part of the JSON object. And I'm going to set in the current position what I just read and increase the position by 1. And then I'm going to print to the serial port the character that I just read so we can see what we got back. Ignore this commented out line. That was me trying to debug something, trying to figure something out earlier. So we're going to sit through this and do this until we get everything back from the server. After we get everything back from the server, I'm then going to set a null at the end of this character string so that I know where it ends, because if I don't, it will read on forever into memory. I by default say that my live stream is down, and I just print a blank line just for cleanliness right here. Well, then I'm going to go ahead and parse. You see some of my debugging code. Actually, I don't need any of this stuff anymore. I'm going to get rid of it just to make it cleaner for later. All right, so I take the data that I received and I put it into a JSON parse, which brings back an object called root. Now, if root's not equal to null, which means it successfully did read and understands the JSON, I am going to come into this routine right here, and I'm going to say that my query, that my value that I'm looking for is this result. So if you remember in the JSON string itself, we saw results colon, and then it's either live or offline. So what I'm saying is after you parse this through this object, I want to look for in this object the value of results. And that's going to point to, query is going to point to that. Then I'm going to say, is the value of this query equal to live? And the way I'm doing that is doing a string compare. So if these two are equal, it will be equal to 0. If they're not equal, it will not be equal, it will be equal to -1. So we come down and if that's the case, we say is live is equal to true, because we got back the result and said we're live now. So then remember by default I said it was false. So unless I see this in there, it's going to remain false. So can't keep that in your head as well. Then as we do this, we drop down and we say if it is live, it's equal to true. Then we want to print to the screen it's live, or print to the serial port it's live. And we're going to turn our control pin 13 high. If it's not, we're going to print the words out no stream, and we're going to put the control pin low. So we do all of this in this condition up here. So we come down past this condition. So if basically we're saying is the root was read okay right here, and we come past the condition. So that we're basically doing here is we're saying root equal to null, and that's just trying to do a cleanup. Something I'm experimenting with. I don't think that it's needed though, but it's not going to hurt anything either. But then we also print out the serial print line. We basically say we're disconnecting, and a blank line to make it look clean. And then we do client stop. And when we do client stop, basically drops the connection to the server and kills the client. The connection should already be dropped anyways, because we're waiting for it to drop before we determine if we continue reading the data or not. And then we drop out. We come back up to here, we wait 60 seconds, and we do it all over again. So let's walk through this one more time. When we come in here, we're going to say by default we're reading, not reading anything. We're setting our array back to 0, and we're creating our JSON object right here. And then we come down and we connect to the server. So we have the IP address, and we're going to port 80, which is the web www interface, or HTTP. If you do like in the browser http:// that's port 80. Versus the HTTPS, which is 443. So I'm going to tell us on the serial port that we connected, and then I'm going to send the command to the server with get space and then this /JSON/channel/TextZenTV /get value of /status. And I'm going to send it using version 1.0 of HTTP. And I send a blank line, which basically says that we're done sending commands, and we're going to wait. So while the client remains connected, like I said, the connection will stay up to the web server until it's done. And when it's done, it will drop the connection. So what we're saying is while we remain connected, we do this, and we just keep going on a loop for forever until we're not connected anymore. And then if there's a client say we have a character waiting, we're going to come in here, we're going to read one character at a time through this while loop. So we'll come through, we read, and by default, we start out with not reading. Reading is equal to false. You can remember reading is equal to false. So we're going to go through like 4 or 5 lines of header information. And probably what I'll do is we'll set reading equal to true, and we'll show you what it looks like when we run it here. So we keep reading, and then finally we're going to see this bracket saying here's the actual data that we're looking for. So we set reading equal to true, and then when we do that to this loop, from this point on, every character we read in is going to go into this array. It's going to increment the position by 1, and we're going to print it out to the screen. After we're done and the client's not connected anymore, we know we've gotten everything from the server. We're going to basically put a null character at the end. This is C language, so it needs to know where the string ends. Basically, we'll add to the next position a null, and we're by default going to say we're not live because we haven't determined that yet. We're going to parse the JSON we returned, and if we successfully parsed it, we're going to drop into here, or we're going to get the results key pair. That's going to be equal to query, and then inside of that query value string is going to be what's in the quotes after results, and if it's equal to live, then we're going to say it is live. If it's not, we're not going to do it. We're going to leave is live equal to false. Then we come down here and we're going to say is it live, and if it is, we're going to print to the serial port it's live and turn the pin high, and if it's not, we're going to say no stream and turn the pin low. And then down here is basically just cleanup. All we're doing is erasing the route that we defined at the top, telling you we're disconnecting, and we're going to stop the client. So that's what there is to it. So let me do this first. I want to show you what you get back as a header. So this may explain this a little bit. Where's reading equals? We're going to say reading equals true from the beginning. And I'm going to push this out. And I'm going to do a serial monitor. I think I am. All right, trying to get IP address. All right, there we go, IP address. Okay, so actually right here it is. This is the header, HTTP 200 OK, server Apache, X varnish, content type, date. You keep going down this line, and eventually you get to the result we're looking for. Right here it is, results offline. I am currently offline. The stream is offline at the moment. So you see all this stuff at the top we want to ignore. We want to start reading right here, which is why we come over here, and I'll put this back to false. We don't start reading until we see the brackets. Let's do this again. We're going to push back up the real way. And all right, it's there. All right, get an IP address, and there you see we ignored it. Basically, only read in from here to there. That's how quick it is. And right now it says no stream. You see results offline, and me printing out the word no stream. So what I'm going to do is I'm going to bring the stream up. All right, the stream came up. Let's see how fast it is at recognizing that. And this is going to do this every minute. So we're going to be sitting here in a very awkward time because 60 seconds when you're trying to do this seems like an awful long time. But hopefully the next result says that it's now live, and we get back the live result versus the no stream result. See, it says live. There's the result, live, it's live. So you can see the stream. Let's see how fast it takes and sees me go down. So let me go back down. The stream is down. Last time I did this, I think I noticed the stream took almost a minute to determine that it was not up. All right, so I edited out almost probably 40 seconds right there, just so you don't have to wait so long. But you see now it says it's offline. It did pick it up within a minute there that it's offline. So you can see that it sees it's offline. So let's do this. I'm going to restart the Arduino, but I'm going to unplug this Ethernet first, and we're going to see it try to get an IP address. So I'm just restarting it now. Press the button. And this is another thing, we're going to wait a minute each time we try this. And the timeout is a while as well, so there may be a few edit cuts in here as well. All right, so there you see it failed. So now it's in this 1 minute wait period again to try again. But what I'm going to do in the meantime is I'm going to plug it back in. And next time around, it will show you get an IP address. So this will show you, this is something you want to build into your applications or your programs, because you may not have it plugged in right whenever you turn it on. And it's just the way for it to automatically recover. So now we're in a 60-second wait cycle. But while we're in the wait cycle, what I want to do is just remind you that you can normally see us live every Tuesday night at 7 p.m. This is a bad example weekend, or a bad example because I'm recording this on the weekend and going to play it on Tuesday. The main reason I wanted to do it was because the stream going up and down, and then I got something come up family related that I had to do as well. So I am doing it all on Sunday. But we do appreciate you joining live and hopping in the chat room. You can get us automatically downloaded from most pod-catching software like iTunes. All right, there we are, getting an IP address, and we got one. Look, cool, continue, offline, no stream. So we are offline. Let me go ahead and bring it back online, and I'll keep my little spiel going. All right, stream's back up. We love to have you, subscribe to it. That's kind of how we measure our results, is by subscriptions, whether you're subscribing in YouTube or you're subscribing in iTunes or somewhere like that. You can get us on like your Zunes now as well. On BlackBerry. We have a channel in Roku now, so we're getting spread around. And if you don't use iTunes, but if you do, the easiest way to do it is just subscribing to iTunes. You can find us in iTunes, or you can go to the show page and subscribe right there. We have many subscription options on the webpage. We do have a phone number. You can call and leave us a message. If you want to leave us a video or show us what you've created with your Arduino, we'd love to see it. Just record it, put it somewhere like YouTube or Vimeo, send us a link to it, and you might just see it show up. All right, you see we're live again. Our results are back. So you can see what we've done. Our little program is going to check now. Let's think about other things we can do with this. So there are many websites. I mean many websites that can you can check statuses through a JSON or XML or some other kind of method, and you're not limited to just streams. You can do stock reports. If you've created a little program to read results from a certain stock, and it goes above or below a certain percentage of change, you could turn on a light, or whatever. You can have it do all kinds of things with it. There's many different things you can do. In fact, I haven't tried this yet, but there's a site called If This Then That I use for some streams. I think it can even call websites and look up things that you can define. I haven't really tried that yet. That'd be anything to play with as well. So for me, I do want to finish building out the on-air or live, I might just call it live light, so that when the stream is up, the light comes on, and it kind of looks like the old-fashioned on-air light. And when the stream is down, the light's off. It's a very visual thing. If you see the light's not on, something's wrong because the stream goes down. And then I also may try to do this with a couple other streaming services as well, because I've been playing with different ones. Not that I don't like Ustream, but there's other ones out there that I'm just trying to figure out which one's the better one, or maybe multiples. Sometimes people use multiple streams. We're not at the size yet where we need multiple streams, but maybe if I want to like better than Ustream ultimately. That's kind of why I haven't committed completely to Ustream. I'm still investigating different ones. But my goal would be, I want to find something that I can do something programmatically like this to help me tell my statuses as well. I am streaming now to an audio stream for internet radio, and that's my next thing to try. And I hope to take this project a little bit farther. I also like to maybe even try to do this on Raspberry Pi. It would be much simpler for me on a Raspberry Pi because I'm a Unix junkie, so I can pretty quickly write a script in a number of different languages that would do the same thing as this. And even control some hardware using that. But this was something I wanted to do because I'd never done it before on Arduino. My next thing maybe is to try to do it with a wireless connection of some kind versus an Ethernet. So I can just take the light somewhere and plug it in. I'm going to use LEDs for the light, so it's going to be like a real low voltage light. I already have the LEDs. I have everything I need except for the box. So maybe it could be a future project with the Raspberry Pi as well. All right, so that is pretty much it for this week. And like I was just blabbing a little bit ago, please subscribe to us on YouTube or in iTunes or wherever you get your video broadcasts from. You can watch us now on the Roku, and we got more stuff coming here soon. But we definitely appreciate all the support that we've been getting from people. And I just want to also say that if you're watching this was not recorded live. And as you watch this here, you see I brought the stream up and down a number of times, and that would have made people really upset if I was doing it live and they're trying to watch. So that's not a normal thing for us. We do normally record live on Tuesday nights at 7 p.m. Eastern, and we'd love to have you come in and watch us live. That's it for this week. We'll see you next week on Let's Make It.